I'm Hanbyul. I work as a software engineer at Development Seed, and I work as a tech lead for Veda Dashboard. Spoilers, we're going to talk about STAC render extension, but before talking about render extensions, I want to talk a little bit more about the projects that we actually found the need to come up with the render extension, and the project is Veda, Visualization, Exploration, and Data Analysis. So Veda is for Earth data scientists who want to engage in more participations in their sciences, but also for the people who are looking for the open source solutions. Do we need a platform for Earth data science? Considering its size and growth, yes, we need a structure that users can save and manage and analyze the data. But does it mean that we have to invent the platforms? We didn't think so. So EO data community came up with a lot of great protocols and data formats already. So the Veda's goal is not to repeat all this effort. Its goal is to weave all these community standards to offer an integrated experience to save and manage Earth data. This diagram illustrates the components of the Veda. Our architecture is built on the open source solutions such as STAC, file formats like SAR and COG, and open source tools such as pgstack and ttilers. You can see that the data service layer consists of several critical components. The STAC API provides an interface for querying and retrieving metadata of the datasets in a standardized format, and S3 for storage. And the dynamic tile server, ttiler, enables visualization of the geospatial data by creating map tiles on the fly, which are essential for interactive data exploration on the web. And I want to talk a little bit more about the client interfaces, which are in charge of the visualization of the data, because this is a layer that we found the need for the STAC render extension. So the first client that I'd like to talk is a STAC browser. It is an open source work by Radiant Earth. It is a web application for browsing static catalogs. Let's see how it works. How it works together. Its purpose is to surface all the collections of the data catalog. And you can see the details of the data. Let's go back to the slide. And it's great for like browsing and data discovery. And it's especially great if you know what you're looking for. And as an engineer, I can go to the STAC browser and see how the data is ingested as intended. But like as an audience, like do I know what HL, S-drive, and DVI difference data set mean? Like I'm not sure how many people here have like EO data background. I don't. I didn't know what HLS meant, like HTTP live streaming. So like as a general audience, I don't know much about this data set. So this is where the second client interface kicks in, the Veda dashboard. Scientists need to communicate their findings with more audiences, like policymakers and journalists and just general publics. And the science findings often needs like context, like explanation by its expert. Like I don't have much ideas about the NDVI difference, but if it is explained that the negative NDVI index that I'm seeing means that the natural vegetation was washed off after Hurricane Ian, I will have more ideas about what you're trying to talk about it. So that's why Veda offers the dashboard. The Veda dashboard is a web platform with a curated data set for scientists. So it is for scientists so they can present their work accurately, but also they can communicate the works with wider audiences. And to follow the spirit of the Veda, it uses a lot of open source elements while itself being an open source, so the scientists can manage them without paid subscription. There are there are like a Vita instances in the wild already. You can go to this URL and see how it works. Let's also look at it together. This is one of the first instances that we set up. And when you land it, this is a landing page. On the catalog page, you can see the data sets that is curated by the scientists. And the hurricane data set, it has some overview about the data set. And when you explore the data, you can see the collections related to this data set. And you can see the visualization of this data through this page. And this map is also can be used for storytelling. We have blog post types of page, which is called stories. And the map that you're seeing on the left, which is showing the difference between the September 5th and September 30th, that map is basically what you just saw on the exploration page. So how does this curation work behind the scene? Veta Dashboard is using file-based CMS. One data set has one configuration file. And configuration file consists of metadata of the data set and the contents that you just saw in the overview page of the data set. And metadata is written in YAML, and the contents is written in MDX, which is basically a markdown sprinkled with JSX. And each data set also has like group of collections to visualize that you just saw, like the Hurricane Ian data set had 2 collections related to it. This is the repo of the instance that we just saw. And then we can find that Hurricane Ian dataset file here, a lot of data sets. And here we go. Well, GitHub is trying to do this fancy thing, like trying to render like a YAML file as a table, but this is such a big table. So if you saw the raw format, you can see the metadata here and the contents below. And the metadata itself is also consists of 2 parts. Like one is more CMS type data, like a title and description to populate the UIs. And the other types of the data is to fetch the STAC collection and to visualize the collections on the page, like such as collection IDs and then some of the parameters that our dynamic tilers need. To show why you need these parameters, this is one of the example. When I am trying to retrieve some tiles with Hurricane Ian data, when I just pass the assets, I see just black rectangle. I don't know why. Like maybe there's an outlier that makes all the values so small, or maybe just this metadata is missing min and max. So when we pass the rescale values to the tiler, we can start seeing, okay, it looks like a map. And then on the right side, when we pass the color map, we can see the outcome of the visualization. So this is how the source param is the name that we are exposing for scientists, so they can like input their configurations for T-tiler. And this is for Hurricane Ian data. And this is actually, yeah, there should be a comma between -, and 1. It's not -11, but something was going wrong with the GitHub rendering. And this is another example of the NO2 monthly data. It has much more attributes to pass to the T-tiler. And the right is the visualization results. So we've been asking scientists to input this configuration needed for visualization. The problem is that there's really no connection between the ingested data and the visualization other than this one human expert who knows how to visualize this data. So even though I know the STAC collection ID, like I don't have like domain expertise on this data set. So I should always ask scientists, hey, can you put this data in? And also the dashboard is not even only client. There is probably, I don't know, like a lot of notebook that is using this data set. any client that is trying to visualize this data set needs to repeat this configuration. And as you saw, like, it can be error prone, like rescale value was not having comma, and maybe somebody thought that is the actual value for rescale, then you're gonna end up with wrong visualization. So that's where, like, we started seeing some problems of these, like, manual configurations, and it just makes difficult to reproduce the data visualization generally. So we needed a scalable solution that works with our current stack. From here, Chuck is gonna take on.
Hi, everybody. I'm Chuck Daniels, also with DevSeed. So what Hanbyul was alluding to here was the fact that there's rendering configuration information that has to be duplicated in various locations. Let me just go back to that slide very quickly here. A little bit hard to see, but some of these blocks show this replicated data, these source params that Hanbyul was showing earlier. And like she said, we need a domain expert to say, oh, here's how you should render this. Here's a rescale value. So this data set, here's the best way to render it. But that has to be replicated across various clients. So that led us to start to look at, is there some sort of standard we can leverage instead of this disconnection between the metadata that we're grabbing through the STAC catalog and how to render the data. So we look further at STAC, and of course STAC, well, very briefly for those of you who may not be familiar with STAC, it's another standard. It's the Spatio-Temporal Asset Catalog, and it was really created as a common language to describe geospatial information, make it more readily indexed and searched. And it's language agnostic, so there are clients written in various languages. We're using Python in our case, so there's a Python client, but the STAC specification itself is JSON, and a big part of STAC is the fact that it's designed for extension, because the folks who put together the stack and are continuing to work on the specification realize that there's no way they can account for all possible domains. So there's a small common core, but it's built for extension so that if you want to leverage stack metadata and the core doesn't cover something that's specific to your domain, you can create extensions that allow you to cover your domain. So as Hanbyul showed in some of the visualizations, the STAC browser, you can browse through catalogs of data that's been made public, and then just a hierarchy of information, collections, and items and assets. And here's just a quick show that this is JSON, and you can specify items, collections, catalogs, but it's all just JSON data. And as I said, extending STAC, STAC is designed for extension. The expectation is that you create extensions to fully describe your data. That's not covered by the core specification. And these extensions are themselves described by JSON schema. Now, one particular extension was this render extension. So this gets back to what Hanbyul was saying, was that it would be nice to co-locate the rendering information with the rest of the metadata instead of having that split off, sprinkled across the MDX files, these configuration files that Hanbyul mentioned. So the render extension is a way to extend the metadata with information that specifically says, oh, here's the best way to reproject this data. Here's the best color map to represent this data in any sort of visualizations. This works really well with dynamic tilers, but general enough that you can use it with other things. And we'll show a few cases here. And this is just a comparison to show that on the left, we see the render metadata in the STAC extension structure, and on the right is the original information in the app-specific files that the Veda team was using. But that data on the right, as Hanbyul mentioned, was being replicated several places, was not co-located with the rest of the metadata about whatever was being pulled up and visualized in the Veda dashboard. And so by pushing the render metadata out to the STAC catalog with the rest of the metadata, we've now, so this is the transformation of the diagram that Hanbyul showed earlier. So now we have the data expert up front dealing with specifying the render metadata. And now that that is part of the STAC catalog, anything pulling data from the STAC catalog gets the rendering metadata along with the data that you want to render. So now that metadata, rendering metadata, is centralized into the STAC catalog, and any client that's leveraging and querying that STAC catalog is going to get that data along with it if they need to make use of rendering. So we can see here the clients we have here, STAC browser, the Veda dashboard, Jupyter notebooks, they can all just pull the same metadata and get that rendering information. So yeah, this is hard to read, but this is just kind of showing where originally we had to sprinkle this rendering information throughout our specific configuration files in Veda. But now by pushing out, we can see here on the left, we've pushed that rendering metadata all the way out to the STAC collection. And so anything querying the STAC collection, we have a STAC Fast API that we've got in the mix here. And so that's pulling all that metadata and allowing it to be used, as we see on the right, in various rendering scenarios. And here's some more in the browser, in the Veda browser, we can see, in the STAC browser, we can see that we've got thumbnail renders, we've got a map here, but that's all now just using the render metadata that's being pulled from the STAC catalog rather than sprinkled throughout app-specific configuration files. And then here's just an example, again, showing that, we don't show all the details here, but it's effectively within a notebook, we're making queries to the STAC API, and we're getting the render information, and we can use that rendering information to here what we've got. I can't even read this on my screen here, but basically creating a map layer here, and that map layer is integrating that render metadata information to give us a good image here. And that's it, yeah. Basically, we just wanted to centralize the data, allow the domain experts to tell us how best to render the data. And we've got it in a central location, reducing errors, and allowing any client to pull the rendering information without duplication. Any questions? Yeah.
Yeah. So, what kinds of mind is so it's good prescriptive rendering those particular data science collection. The device is to render it this way, and it's part STAC is essentially. But with some eyes trained, so depending on what your use cases, on 5 other ways to learn it, correct? On sound, right?
Yeah, that's a good question. Hanbyul, you want to?
Either great, but there is such a space in both, but I think there's the best way to work on the items level, so it's like getting stats go out of the Swiss items this much.
We're just at a higher this, right? Could you have more than just one?
Yeah, and rolls over the namespace that it can use. So we are putting the rendering here. We are the dashboard at like is better for namespace, and if you have different focuses, you can put that.
Did you want to repeat that? Did anybody not hear that? Basically, the question is, what if you want to be able to render something in multiple ways? So there's we have a namespace mechanism, so you can actually specify multiple sets of rendering parameters and choosing a specific namespace.
It's like, I'm in fair crop science. We did something very similar to this, but we was demo product, the derived product versus the source image that you're rendering from. So like with optimized, to the question about like, we used cell tile or tile cell type. Wordless IMA 132 to understand the pixels that you're rendering. But with that different assets, an NDVI asset, RGB asset, as just an href. In fact, it references that same config in the item. And so that's kind of a source product relationship. So you can have multiple representations from that one stored raster to pan.
Yeah. Yeah, you're saying you can store multiple assets with an item if you want to be able to see it different ways. Yeah.
But it can render on the fly. What they use algorithm instead of expression needs. But yeah, it's good advice.
Yeah. Yeah, there's certainly multiple ways to do it. Yeah, the big thing was we were just trying to reduce the duplication in our application and centralize information. Yeah. Yeah, and of course allow people who have better knowledge on how to render this information than we do.
Well, like even the color, like that could be related when you have multiple allowed setting next. And the person sprays don't use because it's horrible.
Anybody else? Yeah.
We used to stress and breeders, especially around standardized read the syntax that's used for the video detect that that's as the another start wipers from the street in the rates to like 5 minutes and
Should we check that even? I actually, you're more like expression kind of repeat method.
yeah.
I actually, we will have stuck this up in the script as Mike.
Yeah, so we standardize in the possible. So let's see. Yeah, this product we're like taking it even to the next level, standardizing.
Thank you for your presentation. Very excited. Love standardization. So, and it's really great work that you're doing. So you have the expression parameter, and you're passing band arithmetic to it, and I see it uses like B0 for the first band and stuff like that. Is that syntax standardized? Because my understanding is, last I checked, it was being kind of dependent on the num expr library in TI Tyler. Can we work to standardize that, and what are maybe the pros or the cons of that?
Yes. Something has been done. Here, I can use those comics we can read.
Yeah, so one thing I can, I'm not sure that they talked about it because there are a lot of layers to T-Tyler, but one nice thing about the STAC extension is, especially for single band assets, you can refer to the asset key in your expression if you switch on the asset as band parameters. So that takes away some of that kind of that ambiguous territory where how do you refer to specific bands. But there's also a language for, I think it's the BIDX parameter, and I don't think it's expressed in the key in your expression. I think there's a different way. I'd have to look at the documentation, but yeah, I think it's an important thing to try and take it to that level, because if you have to format your STAC metadata like in a very particular way to get it to play nice, that takes away from some of the standardization.
Yeah. Big comment. We got this.
I would actually like to just build on this discussion because I'm doing client-side rendering of single-band geotiffs, and this looks really, really interesting. But since I'm doing it client-side, I'm using OpenLayer's style expressions rather than the T-Tyler query parameters. So I'm curious, how would I have to basically parse out the T-Tyler expressions and convert them into an OpenLayer expression in order to use this?
I think
Yeah, actually, I haven't touched open layers for a while, but I think the centralized information, I think the expressions that T-Tyler is using is pretty, like a color maps, it is derived from the Matplotlib color maps, so I do think you can, you probably have to do some manual, like a transitions in between to make it talk to each other, but I do think that you can still make use of the stack rendering extension, and honestly, like, for your purpose, you can even just change the attribute name for your own purpose. So those are like what we are using because we are like using T-Tyler, but you can change those attributes for your own purpose. Yeah.
Yeah.
So I'm with Taylor Geospatial Institute. So we're literally thinking about things like deploying dashboards for a consortium, but we're deploying on AWS just because that's all I know. Yeah. So is there any specific AWS deployment stuff on GitHub? I haven't gone and looked. Or is it anything that I need to know, other than I think runs on Node or something, right? No secret sauce here. All right. No. So what we're looking at was the Earth data implementation of Veda, right? A second ago, and so I'm looking to do a Taylor Geospatial implementation for, a private data lake type scenario. Is it something we should consider? And if we deploy it on AWS, are there any special things that I need to, consider?
Yeah, I think you can definitely use a really good data. Yes, if you use some private protection, we may probably
Yeah.
be
Okay. I mean, the thing is, I know who to call if I have a problem. Thank you.
Thank you.